So it's not just one or two, there's like thousands on each of these. So you may have heard these being called thin filaments and thick filaments. So this is where this idea comes from, the actin and the myosin. And when the sarcomere is activated, when it gets the signal to turn on, and we won't go through the details of it, but essentially what happens is if you watch this, myosin head actually crawls along the actin and goes up and down, quickly releasing, anchoring in, pulling, and then releasing, anchoring and pulling. And this happens all along the length of the entire myosin over and over and over. To me, one of the biggest things I saw with young kids and even myself in swimming is that it's really hard to get little kids to swim tall, right? So we teach them to have as much distance per stroke as possible, to reach out in front of them as much as possible, and for some reason they find that very, very difficult. It's a difficult concept and they find it difficult to do. Why is that? Can we find a molecular biological reason for this? Now, obviously hasn't been like a test necessarily, but there's fundamentals about how muscles work which I think fit in, and they can help explain. So here on this graph I've got kind of a muscle. I know this is poorly drawn, but you know, this is let's say this is your arm, and here it's really stretched out, right? And as we move along the graph, it gets more and more contracted. And if we graph out the power at each of these levels, so if we just force the arm to stay right there, and we measured how much the maximum power it could create, it's really very little, right? But when we get into the middle zones of muscle, our power output goes up. And then when we come all the way down to the end where it's almost all contracted, the same thing happens. We get very little power output out of it. So there's an optimum window where they work. So putting this into the real world application of swimmers, you know, it becomes really hard to maintain a long, as tall as you can stroke, especially when you start getting tired. As you start getting tired, your brain is saying, keep giving me the same output, keep giving me the same power, but your muscles can't really respond by maintaining the length, right? So it starts cutting things off the edges. It starts not reaching out as far, not going back far enough, and it just wants to stay in the sweet spot here in the middle.